This is WXLJ. I hope you're on your way to the beach today. It looks absolutely good. The temperature's in the 90s.
Yo! I'm maddog Hall, and we're here to see some UNIX turbocharging demos today. It's a nice day. Probably take about 15-20 minutes to do this work, and then I'm going to be off to the beach. If you'd like to see some of this stuff, why don't you come on inside with me? Inside is the first of the demos for the Velociter disk subsystem. This helps to improve or turbocharge your UNIX network by improving the I/O throughput of your already existing systems. Let's take a look and see what's happening. Holy mackerel! There's a lot of people in there. I think I better go and change from my demo. You go on in and watch what they're doing.
What I'm going to tell you today is a little bit about the Velociter program from Digital, which takes advantage of Genroco disk controllers and Seagate IPI disk drives, which provide a product line that produces higher performance I/O than any competitors in the workstation and server market. What Velociter does is makes it possible for people to take advantage of the computing power that Alpha brings to the applications that they're trying to run. The demonstration that you're looking at right now is a comparison between a Velociter IPI disk subsystem running a movie up against a SCSI disk system running the same movie. What you'll notice is that the Velociter disk is playing the movie at a much higher rate than the SCSI disk. You'll notice that the IPI side, the Velociter disk, is producing about 20 frames per second. That translates into a sustained data rate of about 5 megabytes per second. The SCSI disk is doing something on the order of 7 frames per second. That translates into less than 2 megabytes per second. Now, all of this is running through the OSF1 file system. We're also using a previous generation Velociter disk. There are people who already have an investment in S-Bus platforms and are running on run-of-the-mill SCSI drives. The Velociter program will allow for people to buy the same kinds of disk subsystems that will go on Alpha AXP machines to be plugged into S-Bus platforms and run under Sun OS and Solaris. So as a first step, someone who has an investment in a Spark station is going to be able to get access to this technology through the Digital Velociter program. If someone has already made an investment in IPI, because there are thousands of Sun 470, 490, 670, and 690 servers that have VME-based IPI disk subsystems on them, it is possible for them to use that same technology to migrate to a new Sun platform. With Velociter, it is straightforward to be able to take the disk investment that people made in their Sun server and move it to an Alpha platform, thereby only having to make the switch from Sun OS to OSF. I think in a nutshell, what we're doing is bringing supercomputer technology to workstations and servers. The whole benefit of IPI is being able to transfer higher sustained data rates between the disk subsystems and the main computer system than any other technology that's available. Primarily the users of IPI up to this point have been companies like Cray and Convex. The requirements for data capacities, data rates are going to increase beyond any imagination I think the industry has today. The Velociter program and the Velociter products are going to give Digital and Digital's customers the leverage to be able to deal with the problems that they're going to have in this decade.
How did you like that Velociter disk subsystem? Wasn't it pretty neat how you could increase the speed of your system just by adding a Velociter disk drive and increasing the I/O? Now we're going to see how to improve the speed of your network doing something else. We're going to add a DEC OSF1 system with Alpha AXP to the network and we're going to see how the whole network can speed up. I'm particularly proud of this demo because this is my demo. Let's go on in. Let's imagine that these two systems here represent my existing network. Here is my master system in which I administer all of my systems administration information, such as my password file or my host file or my other networking files. And this is my client system, which is taking the information from my master system. As you add clients to your network, you will find that your network is slowing down because there are more and more clients making demands upon the master system. By adding a DEC OSF1 system into your environment, you can create a slave system which will speed up your entire network by delivering the information to the network faster. In addition, I have these systems connected through NFS, Network File System. This allows me to have exactly the same environment on each system. Here we are on the Ultrix system. Let's go up to the application menu and pull down the ICO display. What I'm doing right here is I am running the application on the Sun system and having it display back to my Ultrix system. To stop this demo from running, I go up and I simply close the window. Now let me go over to the Sun system and I will show you how to execute that off the Sun system. On the Sun system, I go to the little icon called ICO. I do a double click on that, and there is the ICO application running on the Sun system. To stop this, I go up to the title bar using OpenLook, press down, and quit. Much the same type of action, is just a different system. Now I go over to the DEC OSF1 system, I go up to the Applications menu, I select ICO again, and ICO shows up. Here's been more or less exactly the same user interface actions on 3 different systems, but what is because of the networking and the compatibility between the networks, I can run the application on any machine and have it display on any other. Let me show you an application that has been ported to DEC OSF1 running on these other systems. XEngine is an application which I have ported to DEC OSF1. Notice that on DEC OSF1 it is running at about 1300 RPM. If I go over to the Sun system, I will do a double click on the XEngine icon. What this is going to do is actually go across to the DEC OSF1 system, run the application on the faster CPU, and display it over the network. However, because it's displaying over the network and because it's displaying to a slower X server that's on the Sun system, it's only going about 167 RPM. Now, let's go to the Ultrix system running on the MIPS processor. Again, I will choose an XEngine, and once again, it is actually the DEC OSF1 system which is executing the application, and it is only displaying on the Ultrix MIPS system. But notice, even though it too is coming over the network, it is still going around twice as fast as the Sun system. This is because digital leads in X server technology, which allows a much faster engine to be running even though it's the same CPU powering the application in all 3 cases. This is an example of going back and having the same application run on all 3 systems, transparent to the user, and having display in a total environment. This is to show that you do not need to have every single application ported to a DEC OSF1 system in order for it to be useful in your environment. All right, the next thing you're going to see is a System 5 user interface demo. This is for System 5 user interface on top of DEC OSF1 for the people who are used to using System 5 systems. You go on in and watch it. I have to go change my clothes again because the boss is not exactly happy with the way that I'm dressed.
One of the exciting things about the DEC OSF1 environment with System 5 extensions is that it's a very robust, standards-compliant environment. Some vendors have been a traditionally Berkeley UNIX shop. They've made the decision to go to System 5 Release 4. And they've basically abandoned all their customers, leaving them with costly porting issues, retraining, and a difficult time getting their job done. DEC OSF1, on the other hand, gives you a modern mock kernel, you get full Berkeley extensions, and you get full System 5 Release 4. In this window, you'll see that we're executing the OSF command ls-a. Here's the output. This is different than the output you'll see from the System 5 command. If you have shell scripts that are Berkeley-based, this is a useful tool to have. In the right-hand window here, you'll see the DEC System 5 extensions command ls-a. You'll note that it is different than the OSF1 command ls-a, and it would confuse shell scripts if you had the wrong version of ls running on a ported application. In the lower left window, you'll see the OSF1 command df-i, which displays your disk configuration. Many people write shell scripts that execute df, and then they edit the output to decide how to perform an operation. In this window, you'll see the System 5 command df-t, which displays the disk layout on the system as it exists. The output format of df under System 5 is different than the output format of df under OSF1. Whatever environment you come from, whatever environment you're comfortable with, you'll find it on DEC OSF1. This minimizes retraining costs, enhances portability, and improves productivity.
Thank you very much, Mr. Gore. The next demo we're going to see is from Kubota Graphics. These are world-class graphics at an affordable price. And this is also taking a little bit longer than I thought it was going to take. I hope it's still sunny outside when I get to the beach.
I'm here today to show you a high-performance graphics workstation that we've developed based on digital alpha microprocessor technology and Kubota's graphics technology in the OSF environment. Our workstations are used in a variety of visualization applications, including medical imaging, strategic imaging, mechanical design, and various scientific disciplines, including computational chemistry and computational physics. I'd like to start by showing you the three-dimensional, the traditional 3D graphics workstation capabilities. What you're seeing here is this teapot rotating at roughly 72 revolutions per second. That happens to be the refresh rate of this screen technology, so the bottleneck here is actually the screen, and the renderer is waiting a lot of the time for the next refresh cycle. So while this is a simple object, it certainly illustrates the very high-performance 3D solids modeling capabilities of our workstation. In addition, I'd like to show you some of the other important special features that are incorporated in our design, which is a very modern design. For example, I'm going to show you different lighting capabilities. Here you see me moving my light. I'm going to move my light so that it's shining from the upper left. I can add additional lights. Now we have two lights. I have a light now shining from the upper right. I can modify the properties of this object. For example, I can make this object very shiny using a technique called specular highlights. And now, if I go back to manipulate my object, you'll observe that I have new properties, advanced features, advanced graphics features in use with this object, and yet I'm paying no visible performance penalties in rendering this object. There are many such advanced features supported by the Denali graphics capability. Another exciting example is the use of a technique called texture mapping, which allows us to take a two-dimensional object, a two-dimensional image, and map it to a three-dimensional surface. In this case, I've taken a marble texture and mapped it to our teapot. In this example, I have a three-dimensional elevation model of the San Francisco Bay Area. What my demonstration allows me to do is draw a flight path over this terrain by specifying control points on a B-spline. And then I can tell my camera, if you will, to roll forward on that path that I've specified. And here you see the outstanding combination of 3D and 2D techniques in a single application. There are various ways that I can manipulate this. You can see my flight path in front, and I can make that invisible. I can, if you will, you can imagine that this is a camera mounted on some kind of vehicle flying, and I can tilt my camera downward so that gradually we're looking straight down at the terrain below us. If I keep going, eventually we're looking out behind the aircraft upside down. And as you can see, the point of this is that the performance is outstanding. I can increase the number of viewpoints that are computed along my path, which will have the effect of slowing the simulation down to a more realistic pace, as well as smoothing the motion considerably. The Denali graphics accelerator is 100% hardware and software compatible with the standard digital product line. Therefore, any software that is meant to be used on a standard Alpha OSF platform will run on Alpha Denali. If the software uses one of the popular three-dimensional applications programming interfaces that are emerging as standards, including PEX, FIGS+, GL4, OpenGL 1.0, if the application uses one of those interfaces, it will not only run on an Alpha Denali platform, but will run accelerated on an Alpha Denali platform, and many such applications are being ported to the platform today.
Oh. The next demo we're going to see is ACA services, which is allowing the different applications on different systems to work with each other across the network. Why don't you go on in and watch the demo? I have to go borrow a suit coat from somebody.
ACA Services provides the mechanisms for clients and servers to communicate with each other across heterogeneous platforms. Now, when I mention heterogeneous platforms, I don't take that lightly. ACA Services runs on HP UX, Sun OS, IBM AIX, as well as DEC OSF1, Ultrix RISC, OpenVMS VAX, OpenVMS AXP, MS Windows, Mac System 7, Windows NT, and AXP. So you can see, ACA Services handles all the problems with data translation and transformation across the different platforms because the API is standard across all the platforms, and it's standards-based. It's based on Corba. Let me click on Message A and watch how ACA Services will go across the network, locate the server process, and if it's not running, it'll actually invoke the process. This offers the added benefit of not having to run your server process 24 hours a day. ACA Services will go out and actually invoke it for you. So if you're in need of integrating your legacy applications across disparate platforms, which most customers are needing today, ACA Services provides this mechanism. It provides the infrastructure, the core, the glue for legacy data and application integration across your entire enterprise.
Come in, they said. Do a few demos, they said. All I wanted to do was go to the beach. If you really want to see something dressed up, though, you can go in and take a look at the CohesionWorks demo in the next room. This is a graphical user interface that ties together all of your different software development tools and makes a really easy programming environment.
CohesionWorks is a product which is utilized in the software engineering area, and it provides distributed access to tools and data across a multi-vendored platform environment. CohesionWorks is built using ACA services, and it implements a Corba-compliant distributed environment which allows access to tools and project data across the network and makes those objects available to the user at their fingertips. Along with the control services provided for the distribution, we offer a Cohesion desktop, which is a graphical user interface to the system, and the DEC Fuse programming tools, which are used for C, C++, Fortran, and Pascal development. If the user requires other tools to aid in the software development lifecycle, they can be easily integrated using the Cohesion toolkit, integration toolkit. We can open up an implementation and unit test tools toolbox, and you can see that we support the full set of Fuse development tools. We can take, for instance, a profiler tool and drag it and drop it on the desktop, and now it will be persistent in that work area. That is, if we close the work area and you reopen it, that tool will now be available. So we can close the toolbox now. What we have is the data and tools in your work area can be distributed across a multi-platformed environment. For instance, if we take this C test.c file and drop it on the graphical call graph browser, we'll actually invoke that tool on the local system here. Now, if this particular tool was unavailable on this system, it will automatically invoke that tool on a distributed workstation. Now, the user can customize that by making selections here and placing them in the current server list, so having a prioritized list of servers for that particular application. If the system is unable to run that particular application on the first server in the list, it will automatically fail over and run the application on another server. We can also do is drag this icon and drop it on the editor. Now, if this editor was running on another workstation in the network, we will actually establish links between this application and the call graph browser to be able to send information between those tools. The call graph browser provides us with a graphical representation of the program structure. And what we're able to do is actually send messages between the call graph browser by double-clicking on a graph element, and we'll send a message to the DEC Fuse editor displaying that particular source line code. This is very, very helpful for debugging and developing your software in this environment. The Cohesion Works product is available today on DEC Alpha OSF1 platform, the Sun platform, and on Ultrix. And in the upcoming year, it will be available on other major UNIX platforms.